When calculating the total demand on an electrical service for a commercial or industrial building with multiple tenants, determining which loads to include can be complex. The question of whether to include specific plug-in loads like a 1500-watt microwave oven and a 12-amp refrigerator, as described, brings up important considerations. Generally, in commercial and industrial settings, small plug-in loads such as these are typically accounted for within the general receptacle circuit calculations. The National Electrical Code, or NEC, specifies a minimum volt amps per outlet to account for these miscellaneous loads. This is usually around 180 volt amps per receptacle. The intent is to cover the expected usage of general-purpose plug-in devices. Therefore, if the receptacle count is already included in the demand calculation, these specific appliance loads might not need to be added separately. However, there are several factors to consider that could change this approach. Firstly, the specific wording of the question is important. If the question explicitly asks for all loads to be included, or if it implies that a detailed load calculation is required, then including the microwave and refrigerator separately might be necessary. Look for key phrases in the question that might indicate a need for greater precision. Secondly, consider the local electrical codes and regulations. Jurisdictions may have specific requirements or amendments to the NEC that dictate how certain loads should be calculated. Always refer to the local electrical code for the most accurate and up-to-date information. Thirdly, the nature of the tenant and their expected electrical usage can play a role. If the tenants are known to have unusually high or consistent usage of these appliances, it might be prudent to include them separately in the calculation. For example, if tenant 2 is a commercial kitchen that relies heavily on the microwave, a more detailed assessment of its demand might be needed. Fourthly, look for clues within the question itself. Does it specify any diversity factors or demand factors that should be applied to different types of loads? These factors are used to account for the fact that not all loads will be operating at their maximum capacity simultaneously. If demand factors are provided, apply them accordingly to each type of load. Fifthly, if the question mentions a single service for tenant 2, it implies that all loads within that tenant space should be accounted for. However, it's important to determine whether the 180 volt amps per outlet allowance is sufficient to cover the microwave and refrigerator, or if they should be added separately for accuracy. To determine the actual demand of the refrigerator, it is important to consider the voltage. If it is assumed to be a standard 120 volts appliance, then the power draw in watts can be calculated by multiplying the current 12 amps by the voltage 120 volts. This gives 1440 watts, which is close to the microwave's 1500 watts. These are considerable loads. It may be a red flag that the question intends you to include it. One approach to tackle this type of question is to first calculate the total volt amps from the receptacle count by multiplying the number of receptacles by 180 volt amps each. This gives you the baseline demand for general plug-in loads. Next, assess whether the specific loads mentioned, such as the microwave and refrigerator, are already adequately covered by this baseline. If you believe that the 180 volt amps per outlet is sufficient to cover these appliances, then you may not need to add them separately. However, if you believe that their usage is significant enough to warrant separate consideration, then add their volt amps to the total demand. Remember to use the appropriate demand factors if they are provided. It is crucial to remember the NEC tables that are applicable for service calculations. For instance, NEC Table 220.42 provides demand factors for general lighting loads and various occupancies. While this table doesn't directly address receptacle loads or specific appliances, it illustrates the concept of applying demand factors to account for non-continuous operation. NEC Section 220.14 addresses the calculation of receptacle loads in commercial buildings, specifying the 180 volt amps per outlet rule. Understanding this section is crucial for determining whether to include specific appliances separately. Let's consider an example. Suppose tenant 2 has 20 receptacles. Using the 180 volt amps per outlet rule, the total volt amps for receptacles would be 20 multiplied by 180, which equals 3600 volt amps. Now compare this to the microwave, which is 1500 watts, and the refrigerator, which is 1440 watts or 2940 watts. If you believe that these appliances will be used simultaneously and continuously, it might be prudent to add them separately to the demand calculation. However, if you believe that their usage is intermittent and that the 3600 volt amps allowance is sufficient, then you may not need to add them. Here is another scenario. Suppose tenant 2 is a small office with only 5 receptacles. In this case, the total volt amps for receptacles would be 5 multiplied by 180, which equals 900 volt amps. Given the relatively small allowance, it would be more likely that you would need to add the microwave and refrigerator separately to the demand calculation. Remember, the goal is to accurately estimate the total demand on the service to ensure that it is adequately sized to handle the expected load. It is always better to err on the side of caution and include more loads than fewer, especially when dealing with critical equipment or uncertain usage patterns. If you are unsure about how to handle specific loads, it is always best to consult with a qualified electrical engineer or inspector. They can provide guidance based on their expertise and knowledge of local codes. In summary, when faced with a question like the one you described, carefully consider the following. Firstly, the specific wording of the question. Secondly, the applicable electrical codes and regulations. Thirdly, the nature of the tenants and their expected electrical usage. Fourthly, any demand factors that are provided. And fifthly, the overall context of the question. By carefully analyzing these factors, you can make an informed decision about whether to include specific plug-in loads in the demand calculation. And remember, when in doubt, consult with a qualified professional or seek clarification from the instructor or author of the test. In this specific case, given the ambiguity of the question and the fact that the microwave and refrigerator are explicitly listed, it would be prudent to seek clarification from the instructor. Ask them whether these loads should be included separately or if they are already covered by the 180 volt amps per outlet allowance. Their answer will provide the most accurate guidance for answering the question correctly. It's important to also understand that commercial and industrial electrical service calculations differ significantly from residential calculations. In residential settings, the NEC provides specific methods for calculating the service demand based on the square footage of the dwelling, the number of small appliance circuits, and the rating of the range and other major appliances. However, in commercial and industrial settings, the calculations are more complex and require a more detailed assessment of the actual loads. This is because commercial and industrial buildings often have a wider variety of loads and more complex usage patterns. One of the key differences between commercial and industrial calculations and residential calculations is the use of demand factors. Demand factors are used to reduce the calculated load based on the assumption that not all loads will be operating at their maximum capacity simultaneously. The NEC provides demand factors for various types of loads, such as lighting, receptacles, and motors. These demand factors can significantly reduce the overall service demand calculation. Another important consideration in commercial and industrial service calculations is the potential for future expansion. It is important to size the service to accommodate not only the current load but also any anticipated future growth. This can be achieved by adding a safety factor to the calculated load or by designing the service with extra capacity. When performing a service calculation, it is essential to follow a systematic approach. This involves firstly gathering all the necessary information, including the square footage of the building, the number of receptacles, the rating of all major appliances and equipment, and any other relevant load data. Secondly, calculating the individual loads for each type of load, such as lighting, receptacles, motors, and HVAC equipment. Thirdly, applying the appropriate demand factors to each load. Fourthly, summing the demand loads to determine the total service demand. And fifthly, verifying that the service is adequately sized to handle the calculated demand. In addition to the NEC, there may be other applicable codes and standards that need to be considered. These may include local building codes, energy codes, and fire codes. It is important to be familiar with all applicable codes and standards before performing a service calculation. Furthermore, it is also important to ensure that all electrical work is performed by qualified and licensed electricians. Electrical work can be dangerous, and it is essential to follow all safety precautions. By following a systematic approach, consulting with qualified professionals, and adhering to all applicable codes and standards, you can ensure that the electrical service for a commercial or industrial building is properly sized and installed. Remember, the goal is to provide a safe and reliable electrical system that can meet the needs of the building occupants. Now, going back to the question about the microwave and refrigerator, let's consider some additional scenarios. Suppose the tenant is a doctor's office. In this case, the microwave might be used frequently by staff for heating lunches, while the refrigerator might be used to store medications. In this scenario, it might be prudent to include these loads separately in the demand calculation, especially if the receptacle count is relatively low. On the other hand, suppose the tenant is a retail store. In this case, the microwave might be used only occasionally, and the refrigerator might be used to store beverages for employees. In this scenario, it might be reasonable to assume that these loads are adequately covered by the 180 volt amps per outlet allowance. The key is to use your best judgment based on the specific circumstances. If you have any doubts, it is always better to err on the side of caution and include the loads separately. Finally, remember that the purpose of a service calculation is to ensure that the electrical system is safe and reliable. It is not simply an academic exercise. The accuracy of the service calculation can have a significant impact on the performance of the electrical system. If the service is undersized, it can lead to overloaded circuits, voltage drops, and even electrical fires. On the other hand, if the service is oversized, it can result in unnecessary costs and wasted energy. Therefore, it is important to take the time to perform a thorough and accurate service calculation. By doing so, you can help ensure that the electrical system meets the needs of the building occupants and operates safely and efficiently. The NEC provides guidelines for calculating the load for dwelling units, but it also provides guidelines and examples of how to calculate the load for commercial buildings as well, but it is not as black and white and allows the professional electrical engineer to use their judgment to perform the calculations. It is important to fully understand the scope of work that is being performed, as well as the current and future needs of the building to accurately assess the electrical needs. Another common mistake is to simply rely on historical data or previous service calculations without verifying their accuracy. It is important to perform a new service calculation whenever there is a significant change in the building's occupancy or electrical usage. Finally, never hesitate to ask for help or guidance from a qualified professional. Service calculations can be complex, and it is always better to seek assistance than to make a mistake that could have serious consequences. One should also consider the use of energy-efficient appliances and equipment. By using energy-efficient devices, you can reduce the overall electrical demand of the building and potentially downsize the service. This can save money on installation costs and reduce energy consumption over the life of the building. In addition to using energy-efficient devices, it is also important to implement energy-saving strategies such as using occupancy sensors to control lighting and using programmable thermostats to regulate heating and cooling. These strategies can further reduce the electrical demand of the building and save energy. Ultimately, the goal of a service calculation is to provide a safe, reliable, and efficient electrical system. By following a systematic approach, consulting with qualified professionals, and adhering to all applicable codes and standards, you can achieve this goal. Remember, electrical safety is paramount, and it is essential to take all necessary precautions to protect yourself and others from electrical hazards. It may also be helpful to create a load schedule. This document will list all of the electrical loads in the building along with their ratings and demand factors. This can be a valuable tool for performing service calculations and for tracking the electrical usage of the building over time. By tracking the electrical usage, you can identify areas where energy is being wasted and implement strategies to reduce consumption. It is also important to consider the power factor of the loads. Power factor is a measure of how efficiently electrical power is being used. A low power factor can result in increased energy consumption and reduced system capacity. Therefore, it is important to correct the power factor of loads with a low power factor. Power factor correction can be achieved by installing capacitors or other power factor correction equipment. These devices improve the power factor by reducing the amount of reactive power in the system. By improving the power factor, you can reduce energy consumption, increase system capacity, and improve the overall efficiency of the electrical system. Another important consideration is the voltage drop in the electrical system. Voltage drop is the reduction in voltage that occurs as electrical current flows through conductors. Excessive voltage drop can cause equipment to malfunction and can reduce the efficiency of the electrical system. Therefore, it is important to minimize voltage drop by using appropriately sized conductors and by keeping the length of the conductors as short as possible. You can use voltage drop calculators to determine the appropriate conductor size for a given load and distance. These calculators take into account the ampacity of the conductor, the voltage of the system, and the distance of the run. By using voltage drop calculators, you can ensure that the conductors are adequately sized to minimize voltage drop. The calculation of conductor ampacity is another important consideration. Conductor ampacity is the maximum amount of current that a conductor can carry safely without overheating. The NEC provides tables that list the ampacity of various types of conductors based on their size, insulation type, and installation conditions. It is important to select conductors with an ampacity that is sufficient to carry the load. If the conductors are undersized, they can overheat and cause a fire. It is also important to dare the ampacity of conductors when they are installed in certain conditions, such as in conduits with other conductors or in hot environments. Darting factors are provided in the NEC tables. These factors reduce the ampacity of the conductor to account for the increased heat buildup. By darting the ampacity of conductors, you can ensure that they are operated within their safe temperature limits. It is equally critical to understand the concept of harmonics in electrical systems. Harmonics are distortions of the sinusoidal waveform of alternating current. These distortions can be caused by nonlinear loads, such as electronic devices, variable frequency drives, and uninterruptible power supplies. Harmonics can cause a variety of problems, including overheating of equipment, increased energy consumption, and interference with sensitive electronic devices. Therefore, it is important to mitigate harmonics in electrical systems. Harmonic mitigation can be achieved by using harmonic filters or by using equipment with low harmonic distortion. Harmonic filters are devices that block or reduce the flow of harmonic current. Equipment with low harmonic distortion generates fewer harmonics in the first place. By mitigating harmonics, you can improve the performance and reliability of the electrical system.